Hey YouTube, AD60M Dennis here, and today I wanted to talk a little bit about the technology that I use, namely the batteries that I use for my radio operation, and in particular some of the changes that have happened over the past, I would say, 2 years that have really changed the way that we can bring portable power around to do things like lunchtime on the air or extended operation when you're off grid. So first off, I remember when I started out, I would say late 2017, I was very concerned about having the right amount of capacity for field operations. So namely, those things that you think about like field days or out camping or something like that. Not necessarily like minimalist and as light as possible, but ways of extending operation time without having an AC outlet available. And back then I had a very power hungry, I still have it, power hungry radio. It's called the FT857D. It's by Yaesu. It's an all mode transceiver, and operating on HF, if I pumped that thing up to 100 watts, it would be drawing like 20 plus amps. And so initially, when I first got that radio, I actually got a 7 amp hour sealed lead acid battery. And that battery was, it was good, but I saw that it would start to really drain after an hour or so, pretty noticeably on the power meter in the radio. And then I upgraded to a 35 amp hour battery, which was heavy. And from there, I used to carry that thing around all the time. And that thing's like a bowling ball. It was pretty heavy. That in addition to all the other stuff I needed to take around. Then I started discovering that people were starting to use lithium iron phosphate batteries, which is kind of a newer technology. It's been around, but it's I guess it's always been pretty prohibitively expensive. So here's a couple things that I wanted to show you. This is still the unfinished form of this battery. It is a 4 Headway cell. They are the 40152S cells. They are, I think, a nominal 3.3 volts, and 4 in series gives about 13 point, what is it, 3.3 times 4? Yeah, 13.2 I think is the nominal voltage of the pack. And what I've done here is I've used this Kepton tape, which is it's a high temperature resistant tape to insulate, well, not to insulate, just to pretty much hold things together. I did kind of wrap the battery management system, this thing right here, this BMS, with that. And the thing here is that this BMS, it's rated to allow 100 amp hours of output. And so here in particular we have this, we have 3 places. This is this here goes to battery minus, so that routes around here to battery minus. This here, it goes to this here goes to the load negative. Load positive goes to the positive port here, and then this little tiny one over here is for charging. So charging uses, I guess, a different set of circuitry there, so that it limits to 10 amp hours. of maximum charge, or what am I saying? 10 amps of maximum charge current. So, you know, if I could charge through this, but then that would completely bypass the protection for overcharging, and it would just charge, you know, upwards of 100 amps and possibly overload the thing. So that kind of defeats the purpose of a battery management system if you don't you know, charge it at the proper current. So this BMS, of course, it has five lead wires. The black one goes to battery minus. Then each of the lead wires goes to the points here that are in between. So you could see like there and there. In between the batteries where they're connected in series. And so what that means is that it's sensing, you know, any voltage differences for each cell, and appropriately allows the charge to even those out. And it's kind of beyond me. What I believe it's doing is it's you know, doing a little bit of resistance maybe, and you know, allowing the other cells that are lower to take more of the voltage, so that they come up and more carefully match the other batteries. Then of course, power poled all the things. Power poles are awesome. They're very easy to set up if you have a crimping tool. Some people like to solder and crimp them. I just like, I think crimping is good enough. And so, you know, you have two separate ports. And again, I said this is unfinished, and that's because you know, I don't like it exposed like this. This is still susceptible to water. It looks kind of shady. You know, it doesn't, if someone doesn't know what this is, they'd think it was a bomb, to be honest, and it's not. So I want to put it in a case, and that's why I kind of have the wires set up like this, so that it would be a little bit modular. And so with the case, I'll have another set of power poles and wiring, and I can set up the right charging port that I want to put on the case, but still have it all connect through power poles. And I think these are 45 amp power pole connectors. These are 30 or maybe 15. Another thing you may notice here, it's kind of underneath here, I'm going to move this, is I have this thing. This is more for convenience that I have it here, but this is a, let me see if I can get it in focus here. This is a 12 volt to 5 volt step down converter, and so with power pole on the end, so 12 volts, and it comes out to 2 3 amp USB connectors. So this allows me to do things like a hotspot, Wi-Fi, charge my phone from the 12 amp battery with 15 amp hours on this. It's definitely a very good storage. That's if you're looking at consumer electronics, it would be the equivalent of a 15,000 milliamp hour phone charger battery. So common sense to us hams, but consumers watching this might not understand that translation, so just thought I'd mention it. So this is again one of the batteries I built when I ordered these Headway cells. Actually I labeled each one, so you see 1 2 3 4, and I took careful starting measurements of voltage so that I could track how it's doing. I ordered 12 of these, thinking I would recreate Julian's his solar, what did he call it? Solar generator. So it would have been 3 of these. So I would have had the bus bars and all that kind of stuff. But I quickly realized that they sent me bus bars, which are these things right here, these bars. They sent me just enough to put all 12 of them in series and essentially I think create a 36 volt battery, and that's not what I wanted to do. So with that I decided to make this pack for portability, and then I would build out the other 8 cells into a heftier battery and then have these wires available to hook them up in parallel if I ever needed to go to the full 45 amp hours into some kind of a case. And that way I could have both portability and high capacity depending on what I wanted to do. So there you have it. Quick overview of my lithium iron phosphate battery, which put together not exactly to plan. Got the parts from China. It's very hard to find a US distributor, and not very cheap. I would say the 12 cells with the holders and bus bars came out to around $400. So you do the math there. But 45 amp hours, I mean, equivalent bio-NO pack would be maybe 3 something. Your choice, really. I wasn't so much into the big sell about building your own and knowing all the parts that go into it, because they're still all coming from China, essentially. So you don't really know what you're getting with BMSs, with cells. It was more about the experience of putting this together and understanding the technology for me. And I really had a lot of fun researching it, understanding it. And it's quite a bit bulkier than some of the commercial offerings. Definitely you can find more compact bio-NO batteries. I think the equivalent 40 amp hour is probably going to be, you know, it's going to be a brick, but it's going to be smaller overall than the 45 amp hour thing that I've built here. But it was fun, and that's what ham radio is all about. It's not like any of our rigs and field setups are the most awesome, efficient setups. I mean, they're all pretty much hack jobs, if you're honest. And so that's what I think about this battery building. I think that we have the means of putting together some of these cool things for our own use. We could say, hey, I built that and I understand how it works. But it's not going to look awesome until you throw it all and hide it inside a case of some sort. Anyway, I just wanted to do that real quick. Get some more practice in for making videos. And so thank you again for enduring my monologues here. No radio operation this time. I just wanted to more talk about some of the technology that I'm using. So hopefully you got something out of that, and give it a try. There aren't only these kind of batteries. There are all kinds of other lithium cells that can be used. And one of my recommendations, if you're not going this route, or even if you are, is check out another YouTuber. His name is Jehu Garcia. I really got so much information from his YouTubes. They're great. That guy's building power walls. He's building, electric skateboards. He built a Volkswagen van, I think, into electric car. So many applications of batteries, mostly ones that he has scavenged from, discarded electronics. So, highly recommended. Very interesting if you're into batteries. Anyway, this is AD60. I'm Dennis. I'm here at work on my lunch hour. It's almost over, so I gotta go. And I just want to say 7-3, and thanks for watching. And here is my TV studio. Much of lunchtime on the air happens, and right now I'm recording a lot of my videos. Pretty nice day today. It's supposed to be raining today, but I appreciate it. Yeah. All right. 7-3, everyone. Talk to you next time. So, that was going to be it for the video, but I got home and I got these. And I was so excited. Let's see what they are. Oop. They are 4-hole bus bars to build the remainder of the batteries. Now, I ordered too many because I wanted to keep my options open. I wanted to rebuild everything later. But the reason I got these is because originally when I ordered the Headway cells, I actually got a bunch of these. They're still here. You can see them. But they sent me just enough to build everything in series. So it would have been a 12 times 3.3 volt single battery in series. Realized that I needed these. And so that actually was a good thing because it stopped me from building the whole 12 cell, the 4 series 3 parallel cell that would have provided 45 amp hours. It would have been a single unit, which would have been huge. And I was ready to do that, but you know, with the time to think about it, I realized that it would be a lot more cumbersome to have something like that. So I'm glad that I built the 4-cell battery, and now I have 8 cells left, so I can make another 30 amp hour 12 volt battery with these. I have the other batteries here, like this is another pack that I have, and these are the individual cells. So let me show you that. So that's battery number 5. I don't know if you can read that there, but it says Headway 40152S 3.2 volts. Plus side, minus side. And manufactured 2019-0110, so they're pretty new. They're just 3.5 months old. So that's 2 of them. I have another 3 boxes here. I also have this is the BMS. So I have a relay here. I don't know if I'm going to use it, but that is, you know, I have an LCD meter that could hook into this and tell it when to turn on and off based on under voltage, over voltage, and all that. Don't know if I'm going to use it. Got the idea from Jehu, and might use that. So now I got to research the box that I'm going to put it all in, but it's all going to come together. All right, likewise I have the cell holders here. These are so these will go like this, not that big. And this is the LCD thing I was talking about. I could probably, oh no, I don't have a 12 volt battery. I wanted to turn it on real quick, but positive cable goes through there, and then basically it reads the amperage that goes through. Don't know how I'm going to use this yet, but we shall see. So got the components, they're slowly coming together here. Just got to figure out how to put it all and arrange it, lay it out. And here we go. Put it together. It's basically the same exact configuration as I had before with the 4-cell, but doubling it. And so what I gotta do now, maybe I should have did this before I put it on there, but I gotta, so it's gonna go 1 bus bar here, 1 bus bar here, right? And then on the bottom, man, this thing's heavy. One of these 4 plates goes here, one here, and then I gotta remove these with a Dremel. I could put one there. Or, I mean, if I didn't want to do that, I could just do 4. 1, 2, 3, 4 of these. But I got to think about that. But that's how it's going to look. And I am so glad I did not build the 4x3 because this thing's heavy. I could work out to this. Oops. Got that curl. Feeling them gains. Oh, yes. Anyway, so there we have it. That's the initial put together. And I think I'll just do a follow-up video because it's getting kind of long already. But I'll get a follow-up video on when this battery is completed. Should probably throw some Kapton tape on all the different terminals so I don't accidentally blow these things up. So that's one thing to think about if you're going to do this. Be very, very careful. Watch your terminals, plan it out. Just like Julian said in his videos, go slow. Figure out what you want to do. And double check it and protect your terminal so you don't short it out. So there we go. Battery build is going to start again. I thought I was going to wait a little longer, but now I got 8 cells to put together and make a new battery. It's going to be cool. Anyway, pretty noisy here with the dog in the neighbor's yard. Sorry about that. I just wanted to say thanks to everyone for watching. Like and subscribe. Follow me on Twitter. This is AD60M Dennis, and I just want to say 7-3. Bye-bye.